productivity is typically used for comparison, but when calculating productivity measures, we always want to make the most thoughtful, most relevant comparison between any two systems, any two crews, or any two options. This particular question is testing our ability to do that. Let's take a look. One road paving crew of 6 people worked 8 hours, okay, I see some factors in here, to pave 25 miles of 2-lane road, while a smaller crew of 4 people worked 12 hours to pave 15 miles of 4-lane road. Which crew, says make a comparison, is more productive and by how much? Oh, all right, now first, let's just back out, look at this words first. Productivity is output over input. Yes, we knew that. Okay, so for this scenario, first off, notice we have 2 crews. I want to organize this information. First crew versus second crew. First crew, second crew. Now, productivity is output over input. So in the situation with these 2 crews, what's the output, what's the input? Sometimes it's helpful to think in words first. Well, they're talking about paving road, that must be the output. Yes, road, okay, some measure of road is the output. And then what's the input? The only thing we're told about is like the size of the crews and how long they worked. It doesn't mention anything else. So the only input here that's being discussed is labor. Oh, all right. So in order to comment whether the first crew or the second crew was more productive, we need to come up with the most relevant ratio of some measure of road to some measure of labor. All right. Now, what I highly recommend before we actually start computing any ratios is let's just organize this data. One road paving crew. Okay, that's my first crew now. 6 people. I'm just taking notes on this crew. 6 people, 8 hours. To pave 25 miles of 2-lane road. Whereas the second crew only had 4 people, but they worked longer, 12 hours. What did they do? They paved 15 miles. They didn't get as far. 15 miles of, wait a minute, it says 4-lane road. All right, now I haven't calculated a single thing yet. I am just organizing the sentences because this format is easier to work with. All right, now I know that in order to comment on who is the most productive, I basically need to calculate a ratio of road to labor. Now, in the case of labor, the denominator, I think I can see this. 6 people, 8 hours is 6 times 8, 48 labor hours. Whereas, oh, that's interesting, second crew, 4 times 12 is 48 labor hours. The 2 crews, in terms of payroll as an input, work the same amount of time. The somewhat trickier part of this, though, is the numerator, the road. You say, well, the first crew, let's just go ahead and calculate this ratio, 25 miles of road, so you put a 25 in the numerator. Okay, 25 miles of 2-lane road. Remember, we want the most relevant ratio, the one that's the fairest comparison of the 2. What's going on here is that this first crew is paving a narrower road. The lanes are a standard size, so they got 25 miles down a 2-lane road, whereas the second crew is paving a wider road, so there's more paving there, 4 lanes. They only got 15 miles down a 4-lane road. What is the most relevant measure? Think of it as like the common denominator between the 2 crews to fairly compare their work. Essentially, the easiest way to do this would be to compare them on miles of lane, because the lane's a standard width. What's not a standard width between the 2 is the actual finished side of the road, but not a problem. In the case of the first crew, I'll just say 25 miles times 2 is 50 miles of lane. divided by, as I had, said before, okay, 6 times 8 is 48 labor hours. Okay, or 50 divided by 48. On my calculator, I get like 1.042. This is actually a partial measure of productivity. There is the first crew's labor productivity, 1.042. The interpretation, 1.042 miles of lane per labor hour, right? Numerator per denominator. Now, is that a good measure? Don't really know yet. Right, have to repeat the exercise over here. Okay, second crew, only 15 miles, but paving 4 lanes reveals that that's 60 miles of lane. Divided by the input, 4 people working 12 hours is 48 labor hours. Or 60 divided by 48, I get 1.25. Is the productivity measure there. 1.25 what? 1.25 miles of lane per labor hour. Oh, now wait, what was the actual question? Which crew was more productive and by how much? Oh, which crew was more productive? With productivity measures, when you're calculating them and making a comparison, you're always looking for the larger number. Larger is always assumed to be better. So, the first half of that question, easy, just look for the largest number. It's the second crew. They're being more productive. The smaller crew, paving the wider road. Now, by how much? A very simple way to answer that is just to comment on what the difference between these two numbers are, like 1.25 minus 1.042. I get that's 0.208. 0.208 miles of lane per labor hour. Okay, that's one way to answer that. We're just providing the absolute difference between the two. Or, actually, a more elegant way to answer that would be by percent. It just gives you some sense of scale. Because when you look at the 0.208, that is an answer to that question, but it doesn't really give you any sense if that's really good or bad, right? If they're winning, so to speak, by a lot or not. Percent difference. The percent difference starts out a lot like the absolute difference, because you still say 1.25 minus 1.042. We're still commenting on the difference, but you divide that by the 1.042. I did that, and well, you get the same old 0.208 in the numerator, but you're dividing that by 1.042, like 0.1996, some odd, or, basically what that is about 20%. The second crew is more productive, and they're more productive by about 20%. Now, if you're wondering about this pattern here, where I took the difference and I converted it to percentage, right? How did I know to divide by the 1.042? Generally, when you're commenting on the difference between two things in terms of a percent, here's a little aid to memory. This minus that divided by that. The tricky thing is remembering what to put in the denominator. The numerator is the difference, but what do you divide it by? This minus that divided by that.